Happy, what is it? Tuesday? Happy Tuesday. Um, in keeping with the strategy of trying not to stay up till 1 a.m. in the morning trying to solve advent and code puzzles, I'm going to use some of my lunch break today to get started on it, and it may carry into a second session later, but hopefully I'll at least get through part one and maybe part two. Uh, okay, so today's puzzle is called Hoof It. We're on day 10. We're quickly approaching my goal. So last year I made it to day 14. I think I made it to day 15, maybe part one, but I didn't get through all the way day 15. So my goal this year is to go at least through day 15. Um, and we're quickly approaching that. So today's day 10. We'll go ahead and jump into this puzzle here. You all arrive at a lava production facility on a floating island in the sky as others begin to search the massive industrial complex. You feel a small nose bump your leg and look down to discover a reindeer wearing a hard hat. A book titled Lava Island Hiking Guide. However, when you open the book, the reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover that most of it seems to have been scorched by lava. As you're about to ask how you can help, the reindeer brings you a blank topographic map of the surrounding area, your puzzle input, and looks up at you excitedly. Perhaps you can fill in the missing hiking trails. The topographic map indicates the height at each position using a scale from 0 to 9. For example, 0, 1, 2, 3. Okay. Based on unscorched scraps of the book, you determine that a good hiking trail is as long as possible and has an even gradual uphill slope. For all practical purposes, this means that a hiking trail is any path that starts at 0, ends at height 9, and always increases by a height of exactly 1 at each step. Hiking trails never include diagonal steps, only up, down, left, or right. Oh, that's nice. We don't have to worry about the diagonals. You look up from the map and notice that the reindeer has helpfully begun to construct a small pile of pencils, markers, rulers, compasses, stickers, and other equipment you might need to update the map with hiking trails. A trailhead is any position that starts one or more hiking trails. A trailhead is any position that starts one or more hiking trails. Here, these positions will always have height 0. So zeros are the beginning of hiking trails. Assembling more fragments of the pages, you establish that a trailhead score is the number of 9. A trailhead score is the number of 9 height positions reachable from that trailhead via a hiking trail. In the above example, the single trailhead in the top left corner has a score of 1 because it can reach a single 9, the one in the bottom of the left. Okay. So I like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's a couple different ways to get there, but basically, because the trail can only reach that specific 9, it has a score of 1. This trailhead has a score of 2. So this trailhead has a score of 2 because it can reach 2 different 9s. Okay. The positions marked with periods are impassable tiles to simplify these examples. They do not appear on your actual topographic map. This trailhead has a score of 4 because every 9 is reachable via a hiking trail, except the one immediately to the left of the trailhead. So there's how many 9s? There's 5 9s in this. Yeah, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you can get to this 9. You can get to this 9. get to this 9, but this 0, this trailhead, there's no way to go from this trailhead to this 9. I mean, you can go directly over, but that's not a good trailhead because the trailhead has to, or the that's not a good trail because the trail has to always increase by steps of 1. This topographic map contains 2 trailheads. The trailhead at the top has a score of 1, while the trailhead at the bottom has a score of 2. So there's 2 9s on this map. There's 2 zeros. This 0 down here, 5, 6, 7, 8, 9, 6, 7, 8, 9. So this trailhead down here can reach this 9 and it can reach this 9. But this trailhead, 5, 6, 7, can only reach this 9. Here's a larger example. So this is probably what we want to use for our test example. This larger example has 9 trailheads. Considering the trailheads in reading order, they have scores of 5, 6, 5, 3, 1, 3, 5, 3, and 5. Adding these scores together, the sum of the scores of all trailheads is 36. Okay. So I definitely am going to have to walk this grid, right? At the very least, I have to walk the grid because I need to find the zeros. Now the tricky part becomes when I find the 0. If it's not a 0, I can just skip that place. But if it is a 0, then I need to basically start to explore the surrounding tiles, and I need to find out which tiles increment by 1. If the tile doesn't increment by 1, we don't need to explore it. But if the tile does increment by 1, we do need to explore it. This reminds me of a puzzle from last year. And I learned on that puzzle that these problems you solve typically with an algorithm called breadth first search. But I don't 100% remember how to implement it. I know you have to have a queue, or the way I did it last year, or learned to do it last year, was with a queue. And so theoretically, the idea is if you start on a trailhead, so you find a trailhead, great. I found a trailhead. Now, if I I think the iterative approach to this is, hold on, I don't think I set up a program CS. Did I? Yeah, I didn't. I'm going to have to write this out a little bit. So we're still going to take the same approach. So we just need to copy this guy. Put it over here. Yeah, so this is where we're going to do our solution. I don't know what this is going to say yet. But The general idea here is I'm going to walk over the grid. I'm going to walk over the grid. I'm going to only worry about places where there is a 0. Then when I encounter a 0, I need to begin exploring nearby tiles that increment by 1. That increment by 1 in each left, right, up, down direction. So I'm gonna have to. We've done this in previous puzzles, but I'm gonna have to have some class or some values to represent direction, right? In terms of the grid, because direction in terms of the grid is just adding. It's adding a value or subtracting a value in a given xy direction to move you to the next xy coordinate of that tile. So I'll need something to represent the direction. And then if I remember last year from this idea of the breadth first search, I basically need 2 lists, or I need um, I need 2 lists. One list to keep track of the places that I've already been, right? Like, oh, I've been to this tile. Don't go to that tile again. And then I need, what else do I need? I need a list to keep track of where I need to go, right? So I think this is where yeah, so this is where I figure out where I need to go down here, right? Any adjacent tile that fits this is a tile I need to also explore. Otherwise, it just gets marked as a tile I've been to. Because theoretically, if we get to this place, if we get down here and there isn't any more tiles to explore, we've come to the end of that trail, and we've come to the end of that trail. Which means before we get here, we need to make sure we haven't there needs to be some step before we start to explore the adjacent things. We need to check to say, am I on a 9? Because if I'm on a 9, there's no more exploring to do. Need to check if we are on a 9 before we explore. If we've already gotten to a 9, then we know we've reached a trail end or the top height. So this would actually be also we should be able to count the score here, or should be able to add the score. And then yeah, yeah, I think that's a good start. I think this is a good place to start. So, what do we want to do first? I think I'm going to have a kind of a similar thing that I did yesterday, where I'm going to have a class called, what do they call this? They call this a topographic map. But topographic seems too long, so I'm just going to call it a topo map. Uh, and the topo map is going to have what in it? It's going to have my grid. Um, and actually, this is going to be pretty simple because I'm just going to say I have a private read-only string array, and this is going to be my grid. And then I'm going to have a private constructor that takes the input and uses the input, or sets the grid that input. And again, the only reason I'm doing this is that reason I'm making this private is so I just can have a little bit of like the API that I kind of like, rather than calling new and passing in the input to an instance. I think it looks a little bit cleaner if you can say something like public static topo map, and then something like from, and give that from input. I'm just going to leave it as from. And then that's just going to, and that actually, there doesn't need to be any kind of transformation at this point done to that input. I can just say new input like that. Now up here, bar map equals topo map dot input. But instead of read all text, I actually want this to be read all lines. You see, I'm not getting any IntelliSense. Did I forget to add this to my solution? .NET SLN add. I guess I must have .NET SLN. I did this. I set this up real late at night last night, so I forgot. Yeah, and then once I have my map, I can pretty much just have what is the sum of the scores of all trailheads on your topographic map. Um, so I think I'm going to start off with a method that just returns me a list of scores. And if I decide that I want just a clean method that just returns me the total, I can do that. But I think having a method that returns the actual individual scores will be better for me to debug and test with. Um, because that's what it gives me in the test. It actually gives me like how many scores I should need for this example input. It actually gives me what scores I should expect to get back. So yeah, so that's what I'm gonna, and then I can just use like link.sum, list.sum to get the total. So I'm gonna say public list of int, and I'm gonna say I'm gonna call this just calculate trail head scores, or should it be like get trail? I'd call it get trailhead scores. And for now, we'll just return an empty list and we'll write some tests. So let's add a test class for tests. First one we need to write is public async task from and called it should new instance top. That's pretty simple. We'll put a private read only private read only string example input. Just be an expression collection or collection expression. We'll take this guy, stick that here. I know writing tests slows me down, and I know I'm slow at it, but man, does it feel good to have tests. I mean, you know what? I forgot. I don't even have any music. Put some music on. Um, yeah, I don't know. It just for me, it feels good to have tests, especially when it comes to stuff like this, because you can kind of get it working. This is a perfect example of that whole idea of like you can get it working, you can make sure you have the correct answers, and then if you're not happy with your solution, it's uh, oh, interesting. Just doing some sort of memory analysis. Um, I'm sure there's memory issues with the code I've written so far in some of the solutions, but to go back to the idea of tests, it's just super nice to have tests that you're confident that they give you the right feedback, and then you can just start hacking away at making the code better, rerun your tests, and make sure, hey, did I actually have a regression? Um, yeah, I just can't imagine people who have to work or code in solutions or projects where there isn't good test coverage. Just not having that feedback would, I think, not be fun. Music down just a little bit. Okay, let's get busy on the meat and potatoes here. Okay, so the only thing we're checking here is we're just going to say var map equals topo map dot from sample input, and then all we want to do here is await assert dot that result is of type and then we can now write another test that says public async task. What did I call it? I called it get trailhead scores. Excuse me. When called with example input, it should return expected values. And var expected values equals new list of int. Those are going to be, I don't know why Writer does that sometimes. It's like I push semicolon and then it puts everything on the line. 5, 6, 5, 3, 1, 3, 5, 3, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 6, 7, 8. Yep, 8. Okay, so those are expected values. Var result equals topo map dot from sample input dot get calculated trailheads, and then we're going to say await dot that await assert dot that result dot is equivalent to our expected values. To be honest, I'm not sure I'm sold on this TUnit assertion library. I mean, I don't have any issues with it, but man, it sure is. The fluent assertion syntax is really hard to beat, you know, where you say result dot should, you know, be equivalent. There's just something about having that chained fluent API that's really, really nice. Which you can use fluent assertion with TUnit. Since TUnit already comes with an assertion library, I haven't bothered with adding it. This is definitely better than, you know, like the standard MS test assertions of like assert dot, you know, is equal. I think the built-in assert really doesn't have a ton of built-in assertions on it. I think I shouldn't say though, because I haven't used MS test that much. Okay, so my first test should fail. Let's go ahead and refresh our test list here. Give it a build. Close. So one should pass, one should fail. Yep, this one fails. It's just empty. Okay, so let's go to the implementation. So, like I said, the first thing, if I remember right from last year, when we did something similar like this, is I need two things. I need, I guess the first thing I need is I need some directions. So I'm gonna have a what am I going to call it? I'm not going to call them rows and columns because rows and columns keep screwing me up. So I'm going to call it record record direction, which has an X direction and a Y, has an X direction, a Y direction. Maybe I just call them YD and XD. And these are just going to be ints. Yeah, these are just going to be ints. And then I think what I did in the last direction thing we had was I created public read only directions. I think it was public static read only direction. Public static direction up, and I think I just set that to new direction, which this would be 0 and this would be -1. Right, because up means we're going, in the context of our map, up is, if we say top is 0 and bottom is a larger number, then up is actually going negative. And so then public static direction down equals new 1, no, 0, 1. And then this is public static direction left. And so left in this context means going this way in our grid. So if we start our grid as numbering as 0, then going left means negative. So this one's going to be -0. And then for right, it's just going to be the opposite. Static direction right equals new 1, 0. And this isn't probably necessary, right? I could just have like a array of tuples. But the reason I do this is purely for just my own sanity, to like help me keep things more organized. So now what I can do is I can go up here and say public, or actually this can be private static direction array. And that's just going to be, oh, I need to give it a name. Directions. And this can literally just be direction dot up, direction down, direction left, and direction right. So like I said, back up here where we were writing out our pseudocode, when I get to a 0, I need to explore those directions. So having that array of directions will let me easily loop over all the directions and then calculate the new XY coordinates by just adding the direction to my current coordinate, wherever I'm at. So okay, so that's one thing I need. The other thing I need, though, is I need those two lists, right? So I'm going to have a list, which is going to be, I'm going to have a list of positions visited, and I want that to be unique. So I'm going to use a hash set. And so then I need something to represent the positions. So I'm going to call this var visited visited positions. And I'm going to call this a new hash set. But I really don't want to just do like a tuple. I want to have a strong type. So I'm going to add another type that's called record position. And this position is just going to be, this is going to have an X, int X, and int Y. X, Y. Oh, and the other thing it needs to have is a height. And do I need to keep track of the height? I honestly don't know if I need to. Do I? I don't think I need to, but I'm just going to do it anyways. Int height. Maybe that comes in handy on the next part of the problem. Yeah, int height. So this will be a hash set of positions. And so as we loop over, we will so as we loop over, we will add to this list. We'll add to this. The other thing, though, we need is we actually need a nut. So this is the part that I learned from last year when you're doing this breadth. I think it's called breadth first search. Is you need a queue that's essentially going to act as what's the next place I should go to. And so we're just going to call this positions to visit, which equals a new queue of type position. And we're just using a queue because of the first in, first out nature of a queue. That's the only reason. That way, whatever we put in, we take out to check next, right? And that just keeps us going in the right order when we're looping. And we're trying to explore all those tiles and then explore the tiles from that tile and so on and so forth. Okay, so we have those. And now we need to start walking the grid. And since I'm going to use these lists to do that, the first thing to do is actually to just to add to the queue. So we can say positions to visit dot on queue, which is basically add is the add method, and we'll say new position, and that position is going to be it's going to be input 0 0 that not input, grid, that's our X, and then this is our Y. What doesn't it like about this? Primary constructor. Oh yeah, you're right. So we're just gonna start at 0 0 but the height is the value. So that's going to be grid 0, 0. So 0th row. And actually, I'm going to say var. I'm actually just going to make this nice and declarative and say starting x equals 0, starting y equals 0, x y, and this is actually going to be starting y and starting x. And remember, the reason why this is y and this is x goes back to that grid column nature, right? So really y on our grid is represented by the rows, which are lines of input, and then the x is really represented by what column you're at in that particular row, which kept screwing me up in yesterday or the day before's puzzle. Okay, so now that we have our starting point in the queue, we can then start looping, and we can basically use a while loop here, because the while loop's a good construct here because we don't want to iterate over whatever's in the queue. We want to iterate as long as the queue has something in it, and in that loop we're going to be also possibly adding to the queue. We're going to be taking from the queue, but then we're also going to possibly be adding it. So we'll say while queue, and we'll say while positions to visit dot count is greater than 0. I doesn't like that. What's the problem? Does this not have it has a count parameter on it? I'm not sure why it's complaining. Maybe it's just because it's empty, or maybe it was just because I didn't type again. Okay, so this is where we're gonna go. If we go back up to our pseudocode, this is where we need to start thinking about what we're doing here. So what we need to do first is we need to get the position from the queue, right? Because since we're not for eaching, we're not for of over the positions to visit. We need to get the actual position to visit. And the way a queue works is we're just going to dequeue, and that's going to give us the first thing that went in is the first thing that's going to come out. So in this case, it's basically going to be the same position that we just added, at least the first time around. So this is just going to be var position to visit is going to equal positions to visit dequeue. Is there a is empty? I guess there isn't any, but I think it prefers that I use the count, doesn't it? Because that's more performant. Okay, now that we have our position, we go back to our pseudocode. Need to check if we're on a 9 before we explore. Yeah. No. Well, yes, we do want to do that. So we do want to say if position to visit dot height It should be a position, right? Position. And doesn't this have a height property on it? Yeah. Oh. This is the singular version of that variable. So position to visit dot height. And so this is where we actually do need the height, because we need to check if position to visit dot height is 9. What do we want to do? If position to visit height is 9, this means that this basically means the trailhead score needs to be incremented. But I guess we need to keep track of the score somewhere. But this feels like the way I'm doing it, I'm going to be keeping track of all the scores and not just the individual. And I have no way of telling which one I came from. Okay, let's just say okay, so let's just, yeah, for now we'll call it score. We'll just say var trail head score. Started at 0. Okay. So for here, we want to increment that and then just continue on to our. But before we do that, remember we're keeping track of the visited positions, and so if we've already got to a place that we visited, then we just want to continue on. We'll say if visited positions dot contains this, and we just want to continue. We don't want to increment the score, right? I think so. I think that makes sense. Yeah, that makes sense. Now, when does something get added to that list? Well, it gets added after we check if we haven't already been there. So if we haven't already been there, then we're visiting it for the first time. So we'll say visited positions dot add. I feel so slow. I feel like I'm just like, I don't know. Redundant contains before add. It's redundant. Yes, it's redundant, but the reason why we're doing it is because we don't want to do anything down here. So it's redundant at the moment, I think, but I don't think it's going to remain redundant. Okay, so if we have checked if we have been there, and we've checked whether the height is a 9, that means we want to explore. So we've reached the part where we're going to explore. So this is where our directions come into place. So we'll say for each direction in directions, we're going to calculate the new point. So we'll say var new position equals our position to visit dot. I'm gonna add a method to this, right? I'm gonna add a method that does that. So we say public position get next. Yeah, get next position, and that's going to take a direction. I'm really happy with the way I did this compared to how I did the other position placement grid classes I did, because this makes more sense. So I have a position, I give it a direction, and it gives me a new position. So how do I get that new position? That new position is going to be var x equals the current x plus the direction dot xd, and then var y is going to equal the current y plus direction dot yd. And because these will be positive or negative, so when I add it, the addition will do the subtraction and addition part, because I'm using ones and negative ones to represent up, down, left, right. And then I need to get the height, so var height. This is going to require me to pass in. It's going to require me to pass in the grid. Yeah, it's going to require me to pass in the grid. Which now it's not so elegant, but I don't want to set this to something else and then return it back and then set the height to bait. I don't want to do that. I don't want to do that up here. So this is just then going to take a thing, and this is going to be the grid, and then the height is going to be grid y x, and this is important to just remember, right? Y refers to our row, and since we're using a string array, the row is whatever line, and the column is whatever character in that line. And then we can do return new x, y, just like that. Which means then up here, all we have to do is we just have to say dot get next position and pass it that direction, as well as the grid. But we can't just do it blindly. Like we can't, because now we can't just explore blindly. Because like they said, the tiles can only be, the tiles can only increase by 1. That's one limitation. We also don't need to add it to our list of things to visit if it's already been visited. We also don't want to add it if it's off the grid, right? So if we are starting here, left and up are going to take us off the grid. Well, that's no good. We don't need to add those. So let's add a method first to check if it's off the grid. So we'll say private if is off grid, and we can give it a position, and then we can say return. So if it's off the grid, what we need to check for is we need to say if position dot x is less than 0, or position dot x is greater than greater than grid dot length minus 1, or this is complaining because this is not a bool. Then we'll check the y. We'll say position y is less than grid dot length. Oh no, y is grid dot length. This should be grid 0 dot length, because remember, x is referring to our placement along a line, and the length of that line is going to be equivalent to the length of one of those lines. Minus 1, because obviously the length is always 1 more than the number of indexes. So position y, and then the last thing we need to check is position dot y is greater than, no, it's less than 0. So if position x is less than 0, that means it's gone too far to the left. If position x is greater than this index, then it means we've gone too far to the right. If position y is less than, if position y is greater than, if position y is greater than grid dot length, it means we've gone too far downward. And if position dot y is less than 0, it means we've gone too far upward. So if is off grid, we can continue. Otherwise, we can say positions to visit dot add not add, enqueue on queue position. But there's another check. So we need to say if it's off the grid. We also need to check if it's been visited already. So we can say if visited positions dot contains new position, then we continue. And I could combine these into one if statement, but sometimes I kind of like them to be individual, because that's kind of the way, at least my brain, that's the way my brain thinks. It's like, okay, is it off grid? Yes, continue. Okay, does the visited positions contain the new position? Okay, continue. And then the last check is we need to make sure the difference in the heights are correct. So the difference between the current position, let's say height difference. So if the difference between the new position, position dot height minus the position to visit dot height, right? If that height difference is not 1, we need to continue. And actually, now that I'm saying new position down here, I don't know if I like having this be called position to visit. I think I'm going to change. It's also kind of confusing because I have positions to visit and position to visit. So I'm going to say rename this to current position. Wasn't it? Let's score. Yeah. And so this should wear itself out. Yeah, this should wear itself out. The only problem with this is I'm not... The only problem with this approach is I'm actually going through the whole grid looking for the trail. I'm not looking at each individual trail. And I kind of want to look at each individual trail. Oh, it's already 1:45. Hold on. I think lunch is over. I think I might have to... Yep, I'm gonna have to take a break. But I think this is actually, I think I'm pretty close to solving part 1. I think hold on real quick before I take a break. I think if I return this now, if I return this trail score, I think this will actually get me the right score. But it'll be the score of all the trailheads. I don't think it will be the score of what I want to return, which I want to return a list of the individual trailhead scores. Yeah, so let me test that theory, because we're not really delineating between the individual trails. We're just basically, because we're walking the grid, we're saying, oh, here's a 0, do the things, and as I'm putting things on the queue and taking things off the queue, anytime I encounter a 9, I'm incrementing that score. And I know, like, I'm not associating a 9 with a particular 0. I'm just saying, hey, I've in-queued all these positions. Whenever one of these in-queued positions takes me to a 9, you can increment the score. Which, this may not be a bad thing, but I kind of don't... In part 2, it might be a bad thing, right? If I'm not keeping track of the association, maybe there's a requirement. Yeah, so we'll go, okay, this is going to return an int. And so now this is also going to be an int. Right? Yeah, that's an int. So that's actually not going to work. So let's just check my theory real quick. So we'll say is equal to, because this will at least confirm that the breadth first search thing, the queue thing that I'm doing, this will at least confirm that I'm like on the right path. So this would be 36. Run. Index was outside the bounds of the array. Where's this at? Oh, okay. Yeah, because whenever I calculate the next position, that's going to take me off the map. When I do this right here, get next position, that's going to take me off the map. Like even the first time through, right? So when I calculate the up direction, I'm off the map. But down here, I'm already trying to access that position. So I actually need to do the check down here, which maybe is a better... I don't honestly know if that's a better design, but I'm going to say pull this down here into the record. I mean, I guess the benefit is that no one position is ever going to take you to an invalid position. And I guess what I could do is I could also say, I could change this method signature a little bit. And I could say, try get next position. And then I could have an out parameter call bar position. And this could be a bool. could say this actually needs to say grid for string input or grid. And then I'm just going to replace all my references to that private, the one I pass in here. And this is going to be nullable. Maybe not nullable. So we're going to return var is off grid equals is off grid, pass it the direction and the grid. Because it already has a reference to those properties. So this can be direction. I know I said I needed to stop, and here I am. I'm just keep going. Well, actually, let's not change. Actually, let's do this. Let's not change the. Let's not change the method signature. Let's keep it that, and let's move that down here. We say is off grid, and we say var position equals new position xy. But for the height, we'll just set a -1. Excuse me. And then we'll say position grid. Oops. Gosh dang it. Grid. And then if it is off grid, we can also say if it is off grid, we just return true or return false because we weren't able to get the next position, and otherwise return true. And then down here we will say position equals new or equals position with a height of grid y x. That. And then we're just gonna, this is probably not the ideal thing. We should probably have like a type that represents a null position. But let's just, in the sake of this, we'll just say, hey, say everyone that calls this is going to know, hey, if you can't get the position, new position, new. So current position, try get next position with this direction and this grid. If it can, it's going to give us that new position. If it can't, then we're just going to return true. Or we're going to return continue. No. This is actually if try get position is false, meaning we can't get the new position. Try that. Expected result to be 36, but found 0. Okay, let's take a look at our input here. So the first time we come through, we're going to have the value 8. So if current position is 9. Oh, we need some way to check if the current position is 0. Right? In Q. Yeah, this is where we should only be. Basically, my assumption I made here was that I'm only running this on zeros. I think is is the assumption I'm making at the moment. Because right now there's no guarantee. Well, let me just debug this. Debug unit tests. We should at least get here. Starting Y, let's see, current position, step over that. Yeah, so current position should have 0, 0, and a height of 56. What? That's not right. Should be 8. 0, 0. Position. Oh, do I need to, hold on, do I need to parse that? Because this is a character. Int parse. Okay, just move this up here and say var starting height equals. Okay, I really do actually need to stop, I think. Sometimes it's hard for me to stop though when I feel like I'm int dot parse up to string because it's a character. Now let's try. I love how I talk so confidently, like I knew what I was doing and how this was gonna work, and now I'm like, I thought I was like gonna nail it right on. Yeah, there we go. So starting height's 8. So it shouldn't contain, so we should skip over that. We should add it. It's not a 9. So then we should start to look in the directions. But we actually shouldn't start to look in the directions because 8 isn't a trailhead. So yeah, I need to have some check that says, hey, if this isn't a trailhead, continue. Yeah. Okay. I need to think about this more. I think I'm trying to solve it. I think when I call this code here, I think I need to make sure I'm already on a trailhead. Is what I think I need to do. So I think I'm gonna have a higher level method that's going to be walking the grid and then calling this lower method. But we'll have to do that later on today because lunchtime is over. And yeah, so I'll see you guys in a little bit. We'll just make this 2 sessions like we did yesterday. And yeah, on we go. Advent of Code, day 10. We're going to get it. All right, see you guys a little later. Good evening. We are back to continue working on day 10 of Advent of Code. So where I left off at lunch was we had basically implemented this method to do a breadth first search, I believe is what it's referred to, but basically we're just going to a trailhead and we're iterating over all the other tiles, and then any tiles that require further investigation, we add those to a queue, and we're just repeating that process. However, I realized that the way I wrote this assumes we're starting on a trailhead, and we aren't actually starting on a trailhead here. So what we need to do is we actually need to lift this up a little bit. So we need to call this get trailhead score. And this can actually be a private method. And then up here, we're going to say public list of int get trailhead scores. And we can actually rename this to trailhead score. And then what we're going to do here is we're going to walk the map. And I'm actually going to go to another project from earlier. So actually, maybe this is cheating. I think it was on 5 where we did this. No, it wasn't 5, was it? Was it 6? Yeah, it was this one. We have a method in here called walk map, which basically does exactly what we need to do, which is we just need to go to every space in every space in a column for every row, and that's exactly what this does. So we're gonna copy that and bring that over to our topo map class. Paste it in there. And this action or this callback is actually going to be a func. Actually, it's just going to be an action, just a parameterless, something to do once we reach this. No, never mind. No, we want those parameters. So then up here, what we can do is we can say walk map And I'm actually going to rename these. So this is not going to be row index. This is just going to be I. I should just rename this in bulk. So F2, we're going to call that I. Input is actually going to be grid. Row. Then we're going to call that, we're going to call this just good old J. And I actually want to switch this so it should be JI. And let's actually call this Y. Call this X. Hey, Kai, can you not do that? There you go. So we'll call back with the current X index and the current Y index. And then in this callback, then what I can do is I can say X, Y. And then I can use this to build up my list. So I can say if or no, we can say var trail scores. There's new list of int like that. And we'll return the trail scores. Then we can say in our callback, we can say var height or var current height equals grid X, nope, grid Y X. Because again, this is a confusing part, right? Because we have a string of inputs. Y refers to what row we're on, up and down, and then X refers to what place in the row. Which has really twisted me up in some problems so far this year. Okay, so the first thing we need to do is we need to say if current height is not 0, then all we're going to do in this callback is we're just going to return. Say int dot parse string. However, if the current height is not 0, then what we're going to do is we're going to get the trailhead score. So this is actually going to take in a position now. So this will actually take in position, trail head. Then what we can do is we don't have to do any of this. We don't have to do any of this. We can just immediately add the trailhead as our beginning node in the graph that we're searching. And then we should be able to now say var score equals get trailhead score, and we'll pass in a new position, which is going to be our X, our Y, and then our current height, which should always be 0. Then once we have our score, we can add that to our list. We can say trail scores dot add. And I don't know how people feel about this walk map method. You could probably just inline the for loops. In this case, you could probably just inline this. But I kind of like the style that I came up with this on the fly working on another puzzle, and I kind of liked it because it's explicit, it's expressive, it gives me control over what I want to do once I get to that current place in the graph or in the grid or the map. I don't know. It looks a little neater, and if you ever have the need to perform that same loop over the map, but alter what you want to do inside that inner loop, once you get to the X and Y coordinate you're interested in, this is flexible enough to accommodate that. So let's see, now we can actually take that off, and we can go to our tests now. Should be able to change that here. And now actually we can actually check for those expected values, which we weren't doing earlier. So we can say is equivalent to expected values. Let's give that a run. Hopefully it doesn't blow up. Okay. Let's see what we got going on here. We do have 9 scores, but they're all zeros. Okay. Or you're telling me nobody ever hits this. Which means no one ever gets to here? Yeah, we just never enter that. Okay, so why don't we ever enter... let's see. Yeah. Yeah, let's just step through this. Like... okay, so X, Y, is that right? Let's look at our map. Yeah, that's our first trailhead. So this should not hit. We should add that. This should not hit. We should loop over the directions, which our current direction is up, which should fail here. Yep. Now our current direction is down, which should succeed. And it should be, we should enqueue this. So step over, that fails. If visited positions contains new position. It does not. the height difference. What? Height is 49. What have I done? Right here. This is what I've done. So what's happening is this is actually a character of 1, and it's being assigned to an int, so there's an implicit casting that's going on. And I'm guessing the ASCII character is 49, which I think is what it was, wasn't it? Yeah. Excuse me. Excuse me. Let's do this. Yeah, 49. Yeah, so it's doing an implicit cast, converting the character to an int value, which is its ASCII value, I think. Yeah, so that's easy to fix, but that's kind of tricky, right? It's probably it's probably, given that I have to do that in so many places, where I have to say int.parse, and then I think I do it in a couple other places. It's probably worth considering that when I construct the map, I should just parse them all to ints to begin with. But that does add a path to your traversal. We can make this static. Well, actually, we don't. Yeah, we can make that static. That doesn't reference. Well, actually, we don't want that to be static. Control, remove that. And we don't need to pass the position. Do we? Oh, no, because that's the new position. So I'm going to actually change the name. Or in this context, it's actually next position. Next position. In which case, we can make this. Yeah, because you could actually have an overload of this. Yeah, right now it's fine. The music is a little too loud for me. Sometimes the songs. For the most part, this website's pretty good. This lo-fi generator, but sometimes it spits out a song that I'm not super. Okay, so now we should be in a better place. Let's run this. Yeah, cool. Okay, so we got all the expected trailhead scores back. which means if we sum them up, we should get the answer we want. So let's go back to our program. And now what we can do is we can actually say, we can call this result. Dot get trailhead scores. And then we can just sum them. That's our result. We can say the sum of the scores of all trail heads is result. Now we should be ready to we should be able to say .NET run project 10. What's the name of this? Hoof it. And then give it the inputs. Away we go. 496. Seems reasonable. That's we had to do something, like I said, we had to do something like this last year, and I didn't know how to do it. And there's actually it was either someone on YouTube or it was in the Reddit threads, because there's a bunch of Reddit threads that you can go and look at how other people have solved the problem in the language you're using too. And last year, that's how this solution, this whole queue, specifically the queue thing, which from what I understand, this is referred to as a breadth first search. I don't have a background in computer science, so some of the very classical data structure and algorithm things are relatively kind of new to me. So that's something I learned last year that came in handy this year. Made this problem seem really easy and make a lot of sense. I don't know if I like this try get next position. I'm not sure if I'm a big fan of these out parameter methods, but I think given the context, it makes sense. I guess you could argue: should the position know about the grid, or should it just know, hey, this is my position. You've given me a direction, and I give you back what the coordinate would be for the next. I think you could probably argue where that belongs. So let's add a method here called private async task, and you guessed it, it'll be get puzzle input, and it will be return await file.read all lines, and it will be path combine app context base directory txt. Now we use that in a test, so we'll say something like test public async task part 1 when given puzzle input it should return expected. Input equals await input or result equals topo map from input get trail scores dot sum. Wait. insert.that result is equal to 6. Awesome. Okay, let's move on to part 2. So let's get our part 2 problem. Continue to part 2. Just gonna preserve this. Copy outer HTML to mark HTML to markdown converter. Paste that in here. Tap back. Okay. And now let's take a read. So the reindeer spend a few minutes. The reindeer spends a few minutes reviewing your hiking trail map before realizing something, disappearing for a few minutes and finally returning with yet another slightly charred piece of paper. The paper describes a second way to measure a trailhead called its rating. A trailhead's rating is the number of distinct hiking trails which begin at that trailhead. For example, this trailhead, the above map has a single trailhead. Its rating is 3 because there are exactly 3 distinct hiking trails which begin at that position. Here is a map containing a single trailhead with rating 13. This map contains a single trailhead with rating 227 because there are 121 distinct hiking trails that lead to the 9 on the right edge, and 106 that lead to the 9 on the bottom edge. Holy crap. Here's the larger example from before. Considering its trailheads in reading order, they have ratings of 20, 24, 10, 4, 1, 4, 5, 8, and 5. The sum of all trailhead ratings in this larger topographic map is 81. You're not sure how, but the reindeer seems to have crafted some tiny flags out of toothpicks and bits of paper and is using them to mark trailheads on your topographic map. What is the sum of the ratings of all the trailheads? So, one thing that comes to mind what comes to mind? So trailheads are going to share or can share potentially positions. So it's not possible. Um, it's not possible to really use the number of positions as a proxy. Let me try. I want to try. I want to see if I can do this. So let me see what happens. My current code. Private read only string test input equals oh, whoops. Let's see. Test. Click. Do that real quick. That there. What? Let's see. I'm just gonna call this test for now because I don't know what this is actually gonna become. Test input. I was gonna say is not. The only reason I'm doing this is so that basically so that I can see what this visited position looks like. So when we return the score, the input string, for the sake of testing, say if character is a dot. Let's do that. Actually, I'll just put this here. Now let's debug our tests. Oh, anywhere we're doing this, we now have to account for the period. So, or maybe we be a good developer or a good programmer instead of assuming everything parses to an int. We say int try parse r out int. We could say if current, if, we could say as height. If has height, and current height is not 0. Down here, we can do the same thing and say if and dot try parse r out bar next position is false. Otherwise, there we go. Okay, so what does this positions to visit look like? Or no, what does this visited positions look like? 0, 0. What have I broken? Broken something, because I don't think this will pass anymore. No, it does. So I thought this should turn up at least one. Zero. How did we get here? Did I not copy and paste this puzzle right? Or did I not understand? Let's see. That's what I would expect, is this current trailhead should be... Well, no, I don't guess I don't know why this is...
Let's go turn off the TV.
I don't even actually know if what I'm doing is helping anything. Height. If current height is not 0, and has height is false. Oh. Has height is false, or is that what I was missing? Yeah, there we go. This is what I was expecting. Next spot. Now, if I get down to here, I expect there to be a score. visited positions equal 18. Which 18 divided by 9 is 2. Divide by 9. No, divide by 8. 0, 0, 1, 2, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what if I didn't do this? What if I didn't do what if this wasn't a hash set? What if this was a list? How many positions would I visit? Duplicate. Well, 18. Oh, well, that's because I'm still checking. Still checking here. I think this might cause a problem, but at 24 we guess 8. We could do 24. What 24 divided by 8 gets you 24 divided by 8. There's 3 maps. So that's what I was thinking was, in my existing solution, I have to go over all of those spots. My search already hits all those spots, but I'm only collecting right now, or in my existing solution, I'm only collecting unique spots, so I'm leaving some off. By changing this to a list and collecting all of them and not checking for uniqueness, I'm actually going to get all the positions I visited. But what I need to check to see is if I change that, does it break my existing solution? Because let's see, because I can still do contains here because I'm using records, so they're still going to compare based on value. So if the next position is already a visited position, I can still continue. So I think this is still saving me. This is still protecting me from the condition I was trying to use the hash set to avoid. Let's see if I do. What do I want to test? I want to test my solution. I want to test this guy. Yeah, so I get a bunch of double up. So, can I? So I do need the hash set. I mean, easiest thing to do would just be to copy paste this method and tweak it. But I don't really care about the score anymore. Yeah. Scores 3. If I back that stuff, make this a hash set again. I debug. Trail score still 3. Wonder why the trail score is 3 though. Shouldn't be, should it? It shouldn't be 3. Yeah. It shouldn't be 3. It should just be 1. Why is it 3? 1 is what I would expect. Yeah, I mean, basically the difference between the score and the rating is um, score and the rating is the number of trailheads that can reach, or a trailhead score is the numbers of 9s it can reach, not the different ways it can reach 9. Let's just start with doing it this way. Get trailhead ratings. Basically going to do the same exact thing. Maybe we're going to use different language. Ratings. That. This will be a rating. This will be get trailhead rating. So we'll have a new private method that's called get trail rating. Takes a position. Is the trailhead. And then we still want to do the breadth first search, but we don't really care. Is there a way we could go the opposite way where we can say to get the trailhead rating, basically need to do the same thing, but like I said, we're just gonna continue. We're not gonna check to see if it's there. I mean, if that's the only difference, we can give this a test really quick. We can also fix this naming situation. So we can say get trailhead ratings. In which case this should be get trailhead ratings is equivalent to new list of int, which is just going to be 3. Get trailhead ratings when given test input. It should return expected. Results 3. This is 3. Oh, it's not equal to, it should be is equivalent because we're dealing with a list. In which case, we do need this. Okay. So I think then I can give it the larger one. Oops, no, I don't want that over there. I want it over here. Test there. Oh, hey, Larry. Yeah, everyone does Advent of Code just super different. You know, this is only the second year I've done it, but um, both years I've done it in C sharp. But yeah, I've seen people do it in Rust. People do it in. There's one guy I watch a lot on YouTube who does it in JavaScript. Um, yeah, it's super interesting to watch how people solve problems. Um, yeah, you learn a lot just by watching other people's process, like how they approach it, and it carries over like just even outside of like these puzzles, right? How do you solve like actual like when you're actually building something that people are going to actually use? How do you think about a problem? How do you clarify the requirements and stuff? I think I'm on. I think I'm on track here. I got the first part done. Now I'm on part 2, but I feel like I have a good handle. But I think what I'm kind of hung up on is I'm trying to reuse as much of the logic from my first solution as I can in my second solution. But I want to see if what I have right now works. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 8, 9. Get trailhead ratings. This and see what happens. Maybe it wasn't as easy as I thought it was. Let's see. 5, 6, 5, 3, 1, 3, 5, 3, 5. I'm way off on some. Instead of a hash set, make this a list. I'm still way off. And I think part of that has to do with the height difference still matters, but whether or not I visited doesn't matter, I don't think anymore. Yeah. So I need to think about this a little bit, about what I'm doing here. I guess I don't really care about the score as much as I do about the positions. Number of positions. What I was trying to do. Oh, it would help if I called the right methods in my test. So let me put this back. Test should be calling get trailhead ratings. There we go. Yep. Okay. So what happens if I remove this? Yeah, that doesn't matter either. The thing is that there's a relationship here between what we see here and what we see here, right? So is that relationship 4? No. Is that relationship the number of 9s? Yeah, it's the number of 9s it can reach. When I'm getting the trailhead, I don't care about the positions I visited. I don't even need to do this. I don't even need to keep track of that. All I do is I follow all paths to 9. All paths to all the 9s. Yeah. Okay. So then what we can do is we can say oh no, that's what we just did. Don't need this anymore. Don't need you anymore. What was the 36? Let's say await assert dot that result dot sum 6. Then down here I can say await assert dot that result is equal to 81. Oh, result dot sum. Okay, those all pass. So now I should be at a point where I can run this against part 2. Need to actually update my program to say bar nums. This can be bar rules map dot get just need the map. And we can say if it is part 2, then it's going to be map.get trailhead ratings. Otherwise, it's going to be map.get trailhead scores. Alt equals nums.sum. And then stat equals is part 2. Is that I should be able to run part 2. 11:20, 19 milliseconds. There we go. So I basically was able to just reuse. So when I was doing the Git Trailhead scores, I was basically just able to reuse that same logic. Because if we go back to the puzzle, the first thing we're doing is we're trying to find how many paths does this trailhead have to, how many 9s can this trailhead get to? So it's kind of like we care about unique paths. Unique paths that end in 9 from the same starting point. Whereas when we're doing the ratings, which is why in my search, I'm keeping track of the visited positions, right? So I'm checking to see, okay, is the current position in the visited positions? If it is, then I just need to continue on. There's no reason to do anything with that position. I've already been there. Same thing with when I'm calculating the new position. I think this is duplicative logic though, because even if I enqueue a position I visited to, I'm going to catch it up here. I think I can remove this check. Watch, I'm going to be wrong, but I think I can remove that check. Yeah, I can remove that check because I'm catching that up here. I don't think I can do it the other way though. Don't think I can just. Can I just remove it from here? Yeah, that won't work because there are times when that current position is going to be 9. I've already been. So but I can remove this. Let's check. Oh, that's probably like a slight optimization. Probably not much. So then basically when I do my other search, when I'm doing the ratings, I don't care about unique paths, right? From same start point, but to different endings. I want to count all possible ways that I can go from a 0 to a 9, right? Which is why I need to get rid of tracking those unique positions up here. But it begs the question to me, if this is so similar, can I extract that commonality in a way that makes sense? So maybe I say we'll try to refactor this real quick. So let's pull a new method here. Let's call it private int get trail paths. Get trail paths. And the only difference between this method and the rating method is 2 if statements, or is actually now just a single if statement. And a hash set. So, I say get trail paths, and I'm gonna have to have a boolean here that says are unique. Are unique. And by default, I'll call this. By default, I'll call this. Whoops. Why am I stuck on that? There you go. By default, I'll say they don't have to be unique. The paths don't have to be unique. Get. Maybe I call it get paths for trail. And what I'll do is I'll say copy all that logic. I'll put that there. And then, oh, I also need trailhead, trail position, trail, that. And the only time I'm going to care about this, so the only time I'm going to do this, is if visited positions dot contains the current position, we want to continue, but we only want to do that if visited position, if are unique. Oh, actually, let's say need to be unique. And make that, to me, that's a little bit more of a clear statement. So if needs to be unique and visited position contains current position, we'll continue. We'll always add, we'll still always build up this hash set. But we won't care about it unless we won't actually use it unless we need to use it, is what I'm thinking. And then we can come down to, so all I'm going to do is I'm basically just going to replace this method call. So I'm going to replace this with get passed for trail. And in the case of the trail head, I need to override that default. And I need to say true. Needs to be unique, true. That, and my test can all say the same because all I'm doing is refactoring the internals of this method. So let's try that. Yeah, cool. And then now we can go up here to this one and we can just say get paths for trail. And that now I can leave that as false because I don't care about them being unique. Okay, cool. So just take that off. So we'll remove this. We don't need that anymore. That's our public method. This is our new refactored method. We don't need this private method anymore. Nice. Yeah. So which I don't know, maybe having separate methods makes more sense based on what the actual use case would be. But I think in here, now we've removed a lot of that duplicate code, and we just have a Boolean we're switching on. Now, to be fair, we are building up a collection maybe when we don't need to. We could probably even wrap this in an if check, but I think it's fine for what we're doing. Yeah, I'm actually really happy with this solution. I'm really happy that I remembered how to do the breadth first search to explore all the different paths of the graph. That was something I learned last year, so I'm happy that pattern recognition came back for this year. Last thing to do is to add a test for our puzzle input for part 2. And set it, we get the ratings. And let's see, that should be equal to 1120. Cool. And then, since I'm not going to probably revisit any of this, I'm going to pull these out into separate classes. Space. That's the name of the project, right?
Dad,
Yes.
can
Just in a few minutes, I'm going to finish up this and then I'll be right there. Separate class 2. Say using. Oh, there's already using statement there. We'll pull this into a separate class. Put this in the same namespace. Yeah, awesome. The line there. Sweet. That's gonna get us to the end. Feature. Oh, I need to update the README. I keep forgetting. Problem. With it. And just to make sure, recognized the solution for this based on pattern of matched last year. Logged using BFS, which is breadth first search. I think that's what we're doing here. There's breadth first search and there's depth first search. Breadth first search. Q. Yeah, breadth first search is a fundamental graph traversal algorithm. Begins with a node, then first transverses all of its adjacent, which is what we were doing, where you can think of the grid as a graph, the trailhead is our start position, and then all the tiles around it are its nodes. And so each time you go to another node, then you explore that nodes, and you just keep iterating over that. And the queue is used so that as you're visiting those nodes, you add it to the queue, and then because a queue is first in, first out, when you come back through your loop, you're always going to take the most recently added, no, the most recently added, or the first one, right? The most, which I guess in the case of our loop would be the oldest one that we added, and we'll start with that. But there's also depth first search, and I don't remember what the difference is between breadth and depth. Oh, breadth uses a queue data structure for finding the shortest path. Depth first uses a stack. So breadth first explores all nodes at the current level of a graph before moving to the next level, while depth first search explores as deep as possible down one branch of the graph before backtracking to explore the other branches. Which I don't think depth first search would have been helpful here. Would it have? I don't know, maybe it would have. But the breadth first search seems easier to understand for me in this problem. Yeah, so that's I think that's one of the important things about why you do this. If you do this advent of code year after year, one, you'll be able to learn stuff every year, but then two, you'll actually be able to see yourself make gains in your ability from year to year, which I've definitely been able to see in myself, which is a nice reinforcement, right? To keep working at the skill. So format with save that. Okay. Now we're ready to commit. And add that, and we'll say feature day 10, or no, solved day 10, part 1 and part 2. Yeah, push it up. Awesome. Okay, well, I think that's going to do it for me. I'll probably stay up tonight and get day 11 ready when it comes out, but that's going to do it for actually puzzle solving for the evening. If you're doing admin of code, I hope you're having fun. Hope you're having a good time. If you're watching these videos after I've uploaded them to YouTube, maybe it's helping you solve the solutions or learn a little bit more about how I solve the solutions. I hope you find them helpful. But either way, I'll see you for the next one.